Hey my friends, my name is Aladdin and welcome to my channel. Right after going through all your comments and reading every single one of your questions, I knew I had to make this video. I decided to dive incredibly deep into the new feature Bambu Lab added for creating threads right inside the Bambu Studio slicer. So before we jump into the secrets, don't forget to support the channel by hitting that subscribe button and smashing the like button. So looking at your comments, the #1 question you guys kept asking was, Aladdin, how do I make a long bolt without completely ruining the pitch? As you know, the pitch is simply the distance between one crest or thread and the next on your bolt. Another massive question I kept seeing was, how do we design a 3D printed nut that actually fits perfectly onto a commercial hardware store bolt? Well, in this video, we're going to answer all of these questions once and for all. Not only will I show you the secret workaround step by step, but at the end of this video, I'm giving you a complete reference matrix table. With this table, you'll be able to make any custom size you want using nothing but the built-in Bambu Studio feature. All right, let's kick off the explanation and uncover the hidden mechanics inside this Bambu Studio feature that the software doesn't explicitly tell you. To make sure we are completely on the same page, and to test this scientifically, I designed a specific headless test bolt inside SolidWorks. The very first thing we need to understand is that in the real engineering world, every single type of standard bolt and nut has a fixed, dedicated pitch. For example, for a standard M10 bolt, the ISO standard pitch is exactly 1.5 millimeters. Let's not just take my word for it. Let's pull up the model and verify this live using the built-in measurement tool right here in Bambu Studio. As you can see right here on the screen, when we measure it using the Bambu Lab tool, the result is exactly 1.5 millimeters, just like I told you. So the million-dollar question here is, does the thread generated directly by the Bambu Lab tool come out standard compliant by default? The short answer is no, absolutely not. All right, before we apply our secret formula, let's actually verify the default pitch generated by Bambu Studio on our bolt to see exactly what went wrong. As you can clearly see right here on the screen, the measurement tool shows a pitch of 2.1 millimeters, which is way larger than the 1.5 millimeters engineering standard. And here is a hidden trap that trips everyone up. No matter what length you type into Bambu Studio, the slicer always generates exactly 5 turns of threads. It doesn't matter if your bolt is 5 millimeters long or 20 millimeters long. It will always squeeze or stretch exactly 5 threads into that space, because the number of turns is locked at 5. As you can clearly see right here, even if we increase the length and stretch this bolt out to 15 millimeters, look closely at the model. The number of threads stays exactly at 5. So, how do we force Bambu Studio to make a standard compliant thread? We have to use a simple mathematical trick. Since the slicer is locked at 5 threads, we calculate our required tool length like this. Required length equals standard pitch times 5. Let's put this into practice for our M10 bolt. The standard pitch for M10 is 1.5 millimeters. 1.5 millimeters times 5 equals 7.5 millimeters. All right, let's start fresh. Let's generate a brand new bolt and nut from scratch. But this time, we're going to apply our golden rule and set the depth ratio directly to exactly 7.5 millimeters. Let's hit enter and see if the thread pitch finally lines perfectly with the real-world engineering standard. By the way, quick tip, because a lot of you asked in the comments, Aladdin, my add connector button is grayed out. The fix is simple. You just need to check the boxes for both Object A and Object B right here in the menu. All right, once the button is unlocked, go ahead and click Add Connector Now. Let's enter the exact values from our formula into Bambu Studio. Size. Set this to 10, because we are making a standard M10 bolt. Depth. Set this exactly to 7.5 millimeters, based on our golden pitch formula calculation. 1.5 millimeters pitch times 5. Now let's talk about tolerances. As we already discussed and thoroughly tested in my last video, if you are making both the bolt and the nut out of 3D printed materials, whether you are using filament or resin, the best clearance values to use are 0.1 millimeters or 0.2 millimeters. All right, let's move to a crucial step because a lot of you are getting confused right here. Before you click Confirm Connectors, you must click directly on the orange highlighted surface of your cylinder. If you don't click the surface first and just hit Confirm, the slicer will literally cut your cylinder completely in half, and it won't add any threads at all. All right, now for the moment of truth. Let's verify if our new thread pitch is finally compliant with the standard M10 blueprint. Let's click on the peak of the first thread. Click on the next peak and look at that. The result is exactly 1.5 millimeters. Our formula completely fixed the problem. The thread is now 100% accurate, standard compliant, and ready to roll. Everything is perfect and the pitch is completely standard. Quick tip before we move on. If the nut comes out too thick, you can easily change its height right here in the slicer. Just select the cut tool. Choose how thick you want it and chop off the rest, just like I'm doing right here. It's that simple. All right, everything is perfectly set up for our short segment. But now, let's say you want to make this bolt longer for your project. What should you do? All right, let's select our bolt and hit the S key to open the scale tool. We'll uncheck uniform scaling so we only touch the Z axis. It was around 10.5 millimeters, so let's stretch it all the way up to 25 millimeters. Now look at the result on screen. By scaling it to 25 millimeters, the thread pitch is completely ruined. It completely lost the engineering standard, it's stretched out way too far, and everything we calibrated is gone. It's totally useless. So what is the correct way to make your bolt longer without breaking the standard pitch? Follow me closely right now, watch exactly what I do, and do not miss a single step of this trick. All right, follow me step by step. The very first thing we need to do is break the link between the bolt and the nut so we can modify them separately. To do this, simply right-click on the nut and hit Clone to create a duplicate copy of it. Once you have your clone, go ahead and delete the original nut. Now, using the exact same method, let's right-click our bolt and hit Clone to make a duplicate copy of it. Next, instead of cutting anything, just double-click directly on the head of this clone bolt to isolate it and hit Delete on your keyboard. Let's select our original bolt, then select Center from the menu. Now let's do the exact same thing for our headless thread extension. Now there is something incredibly important we have to do next. We need to merge these two separate objects together. Right-click and choose Merge. Now that they are merged into one assembly, all we have to do is check our starting height. Select the assembly and press the S key on your keyboard to open the Scale menu. As you can see right here on the screen, our current total height is exactly 10.5 millimeters. Before we lift the extension, let's do a quick cleanup so we don't get confused. Go over to the Objects list on the left sidebar and expand our assembly. Look for the headless thread piece we just added and change its name to Connector 2. Now for the final magic trick. Go back to the Objects list, select Connector 2, and click the Move tool at the top. Look at the Z-axis coordinate right here. It says 3.75 millimeters. To stack it perfectly on top of the original bolt without ruining the pitch, we just need to add the total assembly height we checked earlier, which was exactly 10.5 millimeters. Let's double check by pressing the S key on the assembly. Yes, exactly 10.5 millimeters. So let's do some simple math. We add the current position to the assembly height. 3.75 millimeters plus 10.5 millimeters equals 14.25 millimeters. Look at that on the screen. The bolt has grown longer perfectly. The threads align seamlessly, And our 1.5 millimeter standard pitch remains 100% intact. Now that our pieces are stacked, let's hit slice plate and look at the layer preview to make sure everything looks perfect. Look at that. As we scroll down through the layers, you can see the tool path flows seamlessly from the original bolt right into our extension. The layer lines are absolutely flawless, and that is how you double or triple the length of any bolt right inside Bambu Studio without losing your standard pitch. No CAD redesign required, 100% conforming to engineering standards, and perfectly printable. Want to make it even longer? It's simple. Instead of cloning the thread just once, clone it 3 or 4 times. Just use the exact same move logic to stack them on top of each other. As you can see here, I cloned the headless thread 4 times. We will start with the exact same method as before. The first thing we do is center the thread, and then we merge everything together just like we did earlier. After that, we change the name of the connector to connector 3. After that, just like before, we select the assembly and press S on the keyboard to check the height. Here, the height of the assembly is 18 millimeters, so we save this number to add it to the other coordinate. Now let's go back to the assembly list. Find connector 3, select it, and click the Move tool. In the Z box, we find the value is 3.75 millimeters. Since our assembly height is 18 millimeters, we add them together. 18 millimeters plus 3.75 millimeters equals 21.75 millimeters. We enter 21.75 into the Z box, and as you can see, the bolt grew longer perfectly. This is the ultimate method to get a perfect bolt with a flawless pitch, no matter how much you want to extend it. So let's say you want to keep extending it even more. You just follow this exact same method every single time. We center the headless thread, and then we merge it with the bolt. Then, as usual, we change the name to connector 4 so we don't get confused. After that, we check how high the bolt has reached. The value we find here is 25.5 millimeters. We are going to add this number to the Z value of connector 4. As you can see, the result is perfect as usual, and the bolt is now super long. Now we have covered everything in detail. There's just one thing left, the summary table I told you about, and its explanation. Let me explain it. After doing a lot of testing with different materials, I discovered something very important. Printing both the male and female parts in filament or resin is completely different from printing just one plastic part to fit commercial hardware. That is why, after a lot of hard work, I made these 2 tables. The top table is for when you want to print both parts yourself using filament or resin. The bottom table is for a hybrid setup, when you want to combine one printed part with a commercial part. Both tables focus on the 3 most important parameters you need to get a perfect fit. If you liked the video and the explanation was clear, don't forget to support us with a subscribe and a like, and don't forget to turn on the notification bell. If you have any questions, leave them in the comments, and I will answer you. See you in the next video.